Hey, welcome back to the channel. Good to see you again. Thanks for joining. Hope you're all well. Today on the bench I have something a little special. This is a vintage Onkyo Integra A755 Mark II-70 solid-state stereo amplifier. So this is a special unit. I think Onkyo started with the A755 series back in 1971, 1972, and this is the Mark II version, which is updated. It has totally redesigned tone circuits, and they released this one, I believe, in 1974 or 75. I'm not sure, but I don't think this amplifier was released on the world market. I think it was released in only select markets. So possibly you never seen one of these in North America before, but it is a nice unit and a nice vintage Onkyo. So it's got a little story behind it. So the owner brought it to me. He says it works fine. He's happy with it. It sounds great. He's got no issues with it. But the phono amplifier is missing one channel on both phono 1 and 2. And he says he's confirmed that by switching the left and right. Like if he turns it to, I think if he says he turns it to the right channel and listens to right on both speakers, he can listen to it. But if he selects left, it disappears, and if he goes right and left, it disappears as well. And then he said he found a transistor that was knocking around on the inside, and transistors don't just fall out, they get desoldered. So somebody was in here before, removed the transistor. I don't know yet. I'm going to go in and confirm if there's a transistor missing, but for whatever reason this little guy was loose, rolling around the bottom. And this is a 2SC1345. It's got the black leg disease. I don't know if you can see it. It's got black leg disease. And it's a little Hitachi square body transistor. These are notorious for getting noisy and upsetting a lot of things. So let's have a look at this. So on the left side here we got a power switch. And what looks like a little LED. It's white, so we don't know what color that's going to come up as. Speaker switch for 2 sets of speakers, bass and treble controls. They have a really nice feel to them, really heavy, chunky. And then we can select our tone circuit here. It can go defeat on both treble and bass, or we can switch from 400 Hertz to 125 Hertz. The cutoff for the tone controls. 2 kilohertz or 8 kilohertz. So here we got our mode switch: normal, reverse stereo, right plus left mono, and you can listen to either left channel or right channel. And then we have high cut filters, low cut filters, 20 kilohertz, 5 kilohertz, 10 hertz, which is a low rumble filter, and 30 hertz. Loudness control, muting switch, minus 20 dB. It's got a balance control here, and some volume control. Our input selector, 2 auxiliaries, 2 phonos, and a tuner. So it's very capable. We have a phono sensitivity switch down here. You can select between 3 different phono cartridge sensitivities, and a dubbing switch and tape monitor switch. Alright, back panel we have our inputs for our 2 phonos, our tuner, and our 2 auxiliaries. And we have 2 tape loops. Tape 1 is independent. Tape 2 has a DIN connector as well. So you have a choice of RCA or DIN. We have pre-amp out and main amp in connectors here, and then we have a switch to unite them or separate them. On this side, looks like we got a couple protective fuses. These are most likely speaker fuses. I haven't confirmed that yet, but when we get inside and look around. And then it's got outputs for 2 sets of speakers and 3 courtesy outlets, 2 switched and 1 unswitched. Now have a good look at this back panel here and see if you can see anything that's jumping out at you. Maybe I'll zoom in, maybe you can see it better. Nothing yet. Look at the voltage rating, 100 volts, 50-60 hertz. So this amplifier came from Japan, and it is not rated for North America voltage. It is rated for 100 volts. Now, the owner claims he's been using it. I'm not sure if he's just plugging it into 120 volts and expecting it to fly, but we'll have to address this. If it doesn't have a tap for 120 volts, we're going to have to think of something else, because we can't run this at this 100 volt amplifier on 120, 125, because we'll start blowing things up. It's unfortunate there's a few scratches in the paint. There's one here, there's some missing here, and there's a scratch on one side or the other. The paint they put on this isn't very good. It's not really holding well. But let's pull the lid off and have our first look. Everything looks clean. Alright, looks very good. Now somebody's been through here and done a recap already. We have some fine gold caps down here and on this board as well. So this would be our phono stage, I believe. And it looks to me like all the transistors are there. Somebody's replaced the transistors. I've got two SA673s and two SC2309s. These are not original, I'm pretty sure. Somebody's gone through and done a lot of work on this thing. I asked him if he wanted a recap done, and he said no, so I guess that's the reason why. It's been worked on already, and that's why it sounds good. The transformer does not look like we can do anything with, but we will do something over that. Okay, let's see what we can do here. It's got the original output devices. It's a 2SD 180, and it's got a 2SA626 as your complementary pair for the outputs. It's got separate driver boards and power amplifier boards. It's all been recapped. It's quality Rubicons, 105 degrees C. Everything's 100% there. So it's just a matter of tracking down why the one channel in the photo amplifier doesn't work, and see if we can do something with the power supply. So we got 6800 microfarad at 50 volts. Okay. Now this one is rated. I'm looking at some data. There's not much data on this. This has got some regulated power supply stuff going on here. Some pictures. 35 plus 35 watts on 8 ohms. That's the rated output power. It's got some nice specs. Power bandwidth 10 hertz to 100 kilohertz. And this is what I want to see here. 100 volts AC, 50-60 hertz. So maximum power consumption 210 watts. You have to keep that number in our mind for later, because we're going to do some maths on this. But first I want to investigate why this phono stage is not working on one channel. Is it a broken wire? Could be a bad switch too. Or it could be a goof up from the previous tech when they put the caps in. You never know. Okay. Nice job. Alright, first thing I want to do is run some power tests, because I want to see what's going on with this power amplifier and this voltage. So I have my meter connected to my isolation transformer, and I have the ability to different taps. I can select different voltages. So right now I'm at 121 volts, and I can turn it down. Here's 110, 105, 98 volts. Okay, let's start with that first, and we'll see how this goes. I don't know how much power my isolation transformer can deliver, but we're going to do a power test here. Get everything set up. We're on auxiliary 2. Turn it on. Plug it in first would help. Okay. Turn it on. Up to about 17 watts. And we're live, I think. Let's see here. There's no relay. Turn up the volume. Slow down my scope here. Let's turn up the volume and see what we can get for power output. Okay. We're getting clipping, but we've also dropped to 88 volts. So I'm going to turn up the volume on the power. Now we're at 95 volts. And we should have a little more headroom here. So there's clipping right there. We're at 95 volts. Okay, we're at 16.7 volts RMS on the output. Another thing I want to measure is our rail voltages. I hope you can see this. Let's see here. Can you see that? So what do we have here? This is negative 28.5, positive 28.5. Okay. So that should be close to factory spec. We're only 5 volts down on our power. We could probably turn that up a little. Turn down this. Let me try it at a higher setting. Okay, so now I'm at 108 volts. Let's go to clipping. And we're down at 99 volts now because of the drop from our isolation transformer. Okay, 99 volts, and I get 17.08 watts RMS. And what's our rail voltages? $29.7. 29.7. Okay. If I turn this down, our rail voltages go up. So, for example, we're idling right now, 110 volts in, 40.3, really? 40.3, that's quite a deviation. Turn this up, start loading it. Yeah, 30 volts. That should be our supply voltages, plus minus 30 volts. That's with 99 volts input. We're consuming 145 watts, 1.73 amps. Okay, we got to keep remembering these numbers because they're going to all be important in the future. Okay, I just want to test the phono stage. So I got it connected to phono 1. Doing a 10 millivolt signal. Let's turn it up. And yeah, we have one dead channel. It's an interesting waveform it produced. breaking into oscillation. What is going on here? Something is wrong with this phono stage. Turn up the sensitivity. Something is not right there. Okay, what I want to do is I'm feeding a signal in, phono stage, turning it on. Got a 440 hertz tone. And one channel is dead. So let me get something here. Shut that tone up for now. So this orange wire here should be from our feed from our phono stage to our input. This is all tape monitor switching here. And then it goes on to the volume control. After the tape monitor switching, it goes through the volume control and then the tone board. So I should be able to touch here. That says left in, but it's actually, I'm hearing the right channel. Right channel set on the right. That's backwards. Is it? Yeah, because I'm on reverse. Okay, that makes sense. Okay. Left channel. Right channel is very quiet. But I can hear it. Okay, let's try the volume control. Left channel. Right channel. Problem here. Left channel. Okay, that's working there. Let's go farther back. Let's go here, left channel. Right channel. I'm hearing nothing here. Right channel, nothing on the left. So something here is not working. Bass. 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 Nothing. Bass. Nothing. So something in this amp is dead. Just want to see if we have power supply going to both amplifiers. I think there's a couple power transistors here. I think these might be regulators, voltage regulators. I'm not sure though. So let's have a look. Emitter, 2.6 volts there. Emitter, 2.0. Base, 3.2. 2.6. There's definitely an imbalance here. What is it? Collector. Let's check the collector. 19.5. 19.5. So maybe we have a dead Zener. Now I don't have any schematic for this, so I'm just working off intuition here. Okay, so there's 3 wires here coming. I'm assuming this is power. There's a black, a green, and a gray. Black will be 0, ground, which it is. Green, minus 20.5, gray, plus 21. Okay, minus 20 here. minus 20 there. .6, 2.0. What I'm going to do is I'm going to pull the bottom off. There's a cover that covers just the phono stage here. I'm going to remove that cover. I'm going to inspect the PCB board from underneath. Now I'm not really seeing anything in here that's jumping out at me, but whoever did the soldering didn't clean up after themselves, and there's like rosin flux everywhere. There is a blob of circuit glue here, but I don't think that would cause the problem. But what I want to do is I just want to remove this board from the unit and then pull it out, and then I can inspect it properly, and then I can make sure that switch is 100% too. So just give me a minute, I'm going to pull this board out. Okay, so what I did is I removed 4 screws from the back and 4 screws from the board, and remove the C-clip here so that this shaft can slide forward, and pull it out from this splined switch shaft, and it can just, you can pull this forward, that out of the way, and then the board is free aside from the wires. And look, I already have a broken ground connection here. I'll have to make sure I re-establish that. But we've got full access, and I can do a good clean on this and then inspect it. Let me dig off this circuit glue first. I don't think this is the problem, but it certainly can't help. Okay, time to clean. I have a suspicion there's a solder bridge somewhere. This is what I'm looking for right now. I can't really see anything. I'll keep cleaning and I'll bring you back in. Alright, so I took the board out, cleaned it, gave it a good inspection. Couldn't find anything wrong with the solder joints. No cracked solders, no bridges that I could see. Tested the semiconductors, they all test fine. Checked the orientation of all these capacitors that were replaced, and they seem fine. The only thing I saw that was wrong was this wire that was broken off. And these two here, this green and this orange, that goes to the phono sensitivity switch, which sets up the gain for the amplifier. Now, one of the wires is broken on the right channel, but our right channel was working. Our left channel was not. So, I don't know. I'm going to turn this on, and we're going to listen to, feeding it a signal right now. Plug it in. And let's see, we have a tone. Something coming through on the left. But it is very attenuated. The right channel is better. That is really weird. So I wonder, let's feed it into the auxiliary. Let's try tuner first. Left to right, both working, but our phono is not. We have something. I'm plugged into auxiliary, that's why it's not. Let's plug it into phono. It is there, it's just quiet. Yeah, we got a problem, and one of these amplifiers is not putting out. Either something shunting down the signal and reducing the volume, or something is not amplifying to the correct level. So let's do some basic troubleshooting here. Let's try and follow the signal through with the scope, and we'll see if we can pinpoint why we have a low on one channel. Alright, this thing's really starting to irritate me. It's playing on my nerves. So what I'm doing is I'm scoping the output of this board, the signal that goes onto the tape monitor switchboard. Okay, that's my output signal, and you can see it up there in the scope. On this probe I have a 1000 hertz tone, and I'm driving a fairly hot signal, 1 volt peak to peak. And I just want to confirm, because I got a break here somewhere. I got all these transistors pulled out, they tested fine, but I'm still got a break somewhere in the signal path. So let's test this. So if I go here, this is my signal. There's the left channel, and there's the right channel. Okay, that's the signal that goes to the scope leads. And then it jumpers from here down to here. And I should have a signal here. Here's my left channel. And here's my right channel. Okay. If I follow the right channel back, there is a blocking capacitor here, C36. So if I go from one side, there's one side, there's the other. So signal's getting through there. If I go, I'm working backwards in the circuit actually. Instead of working from the front end, I'm working from the back end. Okay, so this is the left channel. This goes to the blocking capacitor. And then if I go to the other side of the capacitor, look at that. Nothing. Absolutely nothing. Is that capacitor open? Is it even connected? Yeah, it's there. So here I got signal. Here I got no signal. Odd. Is that grounded? I don't see anything. There's a resistor here. Yeah, see that signal's getting through that resistor. No signal's getting through this resistor. And this capacitor is open. Looks like I found the cause here. Okay, so let's pull that cap out. Alright, here's our cap. It is a 684, which means it's 680 nanofarads. Hitachi branded. I don't know if you can see that, if it's going to focus. So, when I test it, remember this should be 680 nanofarads, and it's coming back at 1.1 nanofarads, so it's completely open. Well, not completely, but it's hatched. I'm wondering, let's pull the other one from the other channel and see what that one looks like. Give me a sec here, I'll pull that one out. Same thing, 680 nanofarads. Let's see what this one says. This one comes back at 96 nanofarads. Both these capacitors have failed. That is highly unusual. Highly unusual to have both capacitors fail. So let's get some new caps in there. I do have 680 nanofarads, but they are quite a bit smaller. So I might have to do something creative on the board to get them to fit. Alright, so what I did is I tacked on 2 caps on the bottom of the board. They have about 8 different holes here for different sizing accommodations for different caps. And these Chemet caps I buy from DigiKey, they only have short little legs on them. So that's why I mounted them on the underside. Otherwise I could have just put them from above, but this will work. They'll just be out of sight. So I'm going to put this all back together and we'll do a final test. Now, I'm thinking I saw some of those caps on the preamp board. I'm going to have to pull the preamp board and check those caps because these are systematically failing. We're going to replace them now before they go. Okay, it's pretty simple to remove the tone amp from this thing. I think you remove 6 screws and then you disconnect the signal input from the tape monitor switches, and then the whole thing just slides out, you know, as a module, and there it is. And this board here, I'm not sure what this one is. I think it's a power supply of some kind, but this makes really easy service of this. So I'll go through this, make sure everything's 100% here. I'll look at the quality of these tone control switch potentiometers. They're not actually potentiometers, they look like attenuator switches. And then our volume pot. Okay. Actually, this one will come out too. And we'll do an inspection of this one. I want to remove all the traces of this glue. This is going to cause problems in the future eventually. So whoever did the recap didn't remove the glue. And we'll give these boards a good clean as well. Yeah, and I was right. I did see 2 other blue, these 2 blue Hitachi caps. These are 684 as well. Let's try and measure one of these in circuit and see just what it says, because I think we're going to pull these out and replace them as well. Let's connect up. Yeah, this is down to 400 nanofarads. Let's pull these out and change these ones as well. Never seen these poly caps go bad like this. $126 nanofarad. Unbelievable. Another failed one. Okay, and this one was what, 470? No, it was 320. 320, that's half of what it should be. Okay, so let's get a couple more of those. I got lots of them, so we can put a couple more in and we'll be good to go. Now these ones will fit on the board. See, the lead spacing is correct. So let me clear the holes, clear these holes up. This one and this one. Okay. Almost thinking I might check a few other ones too, because these brown ones here, just pull a couple out just to sample them and see how they're doing. These ones are a different manufacturer. And these are odd values too. This is 204. This one here is 104. That's common. 154. 154. Here's a 114. That's an odd value. Special order value. Okay. One goes here. And the other goes here. Okay. It's a huge size difference too. Well, we don't need a 250 volt cap for just doing passing an audio signal. All right. Make sure these are seated properly. I like to make sure they're seated to the board. Okay. So look at that. 4 failed Hitachi capacitors. These blue ones, I don't know if everybody's seen these fail before. You get a good look at one of these. Is that coming in focus? $250 volts, but they're no good. Okay. Let's pull this one out and test it. I have a feeling it's going to be just fine, but I want to make sure. So this is a 204, it's a 200 nanofarad, so it should come out at, let's see what it reads, 208. See, that's perfect. Within tolerance, and everything's good. So put this one back. Alright, I'll give the board a clean and then I'll reinstall it. Alright, I'm going to leave this one here for this week. I'm going to end it here. I did a lot of work on this one. I chased my tail actually, checking on a lot of things which I usually suspect would be wrong, and they weren't. And what I didn't suspect was those caps going bad. So did spend a lot of time on this. And it's, what is it, Wednesday right now, and I have to get this ready for Friday's release, so I don't think I have time to do the second part of this. I still have a lot to do, and we're going to get into that next episode. I also spent a lot of time on that brand, so I'm working on that one right now, and it's really giving me fits right now. It seems like it's cursed, and it's out to get me, and and it just feels like I'm getting beaten down by it. So I'm gonna cut this video in 2 pieces, put them up as 2 parts, and I know you guys like the long version, but I'm just going to keep it short this week. So take care, and we'll see you on the next one. Thanks for watching, and stay tuned for part 2.